Welcome to my YouTube channel, TED Talks Philosophy. In this series, we're going to talk about causation. We're going to learn about the nature of causation, a bit about causal inference, and some of the complexities that arise with a philosophical analysis of causation. So for this introductory series, I'm using a recent book by Stuart Glennon, Causation, the Basics. It's one of these short books that came out in Routledge's Basics series. I highly recommend this book. Go on Amazon or to Routledge to get a copy. Okay, so let's start off with just some general remarks about causal understanding. Obviously, a large part of understanding the world involves understanding what causes what. Why questions are very basic, as every parent knows. Children love to ask why and follow it up with another why question. We can understand why questions as trying to get at some sort of understanding, and oftentimes this is causal understanding. So, for example, the ancients looked up at the sky and they saw planets appear to wander across the night sky, and they wanted to know why is that the case. Fixed stars apparently don't move from the vantage point of the Earth, and so the question is what explains the movement of the planets. As we know, the visible planets exhibit retrograde motion, Mercury, Venus, Mars, Jupiter, and Saturn. And retrograde motion is the apparent backwards motion of these planets as observed from the Earth. The phenomenon occurs because Earth and the other planets are orbiting the Sun at different speeds and distances. When the Earth passes by or is passed by another planet in its orbit, the other planet appears to move backward in the sky temporarily. Another very basic why question is, why are there tidal movements? Plato reportedly believed that the tides were caused by water flowing in and out of undersea caverns. Aristotle is thought to believe that the tides were caused by winds driven by the sun's heat, and he rejected the theory that the moon caused the tides. Now, interestingly, classical Greeks knew of the relationship between the tides and the moon, but didn't understand what the cause was. Aristophanes, a Greek polymath living in the 3rd century, produced detailed descriptions of the tides and their relationship to the phases of the moon. So this was well known, but they didn't understand, obviously, the theory of gravity. Newton's theory of gravity provided the first correct explanation of tides. He demonstrated that the gravitational pull of the moon and the sun on Earth's ocean causes the tides. Another basic causal question is, what causes leprosy? In the Hebrew scriptures, leprosy is associated with impurity and sin. Leviticus chapter 13, verses 45 through 46 says, "The leprous person who has the disease shall wear torn clothes, and let the hair on his head hang loose. And he shall cover his upper lip and cry out, 'Unclean, unclean.' He shall remain unclean as long as he has the disease. He's unclean. He shall live alone. His dwelling shall be outside the camp." But as medical science developed, we know now that leprosy is a long-term infection caused by bacteria, particular bacteria known as Mycobacterium leprae. Infection can lead to the damage of the nerves, respiratory tract, skin, and eyes. Now, these are all cases of a scientific investigation of what causes what. But we can also ask very simple questions like, why did John eat spaghetti for breakfast? That's puzzling. And so what we want is a causal explanation. We want to know what caused John to eat spaghetti. This is something that you don't really need to do science for. You can ask John. Now, each of these questions aim to uncover a bit of causal knowledge, which once we find that, we get causal understanding. So what kinds of questions should an account of causation answer? Glennon distinguishes between 3 broad kinds of questions. They're conceptual semantic questions, metaphysical questions, and epistemological methodological questions. So conceptual semantic questions have to do with understanding the concepts and the meanings of various terms under analysis. So we might ask, what's the meaning of various causal concepts and their relationship to one another? We can ask, what makes various kinds of causal statements true? Second question are metaphysical questions. So we might want to know, what's the nature of causation? What is the causal relation? Also related, does everything have a cause? Conceptual and metaphysical questions are related. Consider, for example, the question, what is water? Now that we have chemical theory, we know that water is a molecule comprising of 2 hydrogen atoms and 1 oxygen atom. But before we had chemical theory, we still understood what water was. We had a concept of water prior to the chemical revolution. And so what happens is, as science develops, our concepts in a way get refined. Third, there are epistemological and methodological questions. How do we know about causes? Can we perceive causation, or is it something that we can only have knowledge of by way of some sort of inference? And if we can only have knowledge of causations by way of inference, how does that inference work? How do we identify the cause when there are many other causal factors? Take, for instance, a spark as a cause of a fire. We know that there are many other causal factors that have to be present in order for this spark to cause the fire. Or how is it that we identify the spark as the relevant causal factor that we note as the cause, instead of just one among many causal factors? Another question we can ask are where causal concepts or common sense concepts are scientific concepts. As we saw earlier, causal concepts occur very early in cognitive development. Very basic why questions aims to get at some missing bit of causal knowledge. It's hard to imagine a young child, for example, without the concept of a cause. A child cries knowing that the cries will cause his parents to come and tend to him. There is an older tradition in the late 19th and early 20th century, up until we'll see where Judah Pearl talks about the causal revolution, where philosophers and mathematicians thought that causation was something that could be dispensed with. So, for example, Bertrand Russell says causality is a relic of a bygone age, surviving like the monarchy, only because it's erroneously supposed to do no harm. So this conception of causation seems to grow out of the development of statistics and Carl Pearson's attempt to put statistics on a mathematical foundation. Pearson, for example, thinks that statistics deals entirely with mathematical relationships between the data. The data is something that you can observe. Given a set of data, you can determine the strength of correlation between those data. Pearson thinks that data and math are objective. Right? The data is observable, the math is a priori, and it's not subject to unverifiable assumptions, or what we might think of trying to peel back and look under the data to determine what causes what. So Pearson and others think that causal relations, in a sense, are not verifiable, and so causal claims aren't scientific. We'll be investigating this line of argument and see whether it holds water. So related to the common sense notion of a cause is the idea that there is the cause of an event. But a more scientific approach might think that there's no such thing as the cause. Rather, they're just a bunch of causal factors, and there are various sort of pragmatic reasons why we would pick out one causal factor as the cause. So these are some questions that we want an account of causation to be able to answer. Another important distinction is the distinction between singular and generic causal statements. So take, for example, these two claims: smoking causes cancer, and John's cancer is caused by smoking. So the first claim, 1, asserts a causal relation between two types of events: the events of smoking and the event of getting cancer. This is something that is generic. It's a causal relationship between two general kinds of events. Whereas 2 asserts a relation between two particular events: the event of John getting cancer and the event of John smoking. So we say 1's a generic causal claim and 2 is a singular causal claim. So what's the relationship between singular causal claims and generic causal claims? We can think of the particular event John smoked, and we could know in general that smoking causes cancer. Does that mean that we can infer that John's cancer is caused by smoking? Not necessarily. John could smoke, he could get cancer, smoking causes cancer, but we can't infer that his particular cancer is caused by his smoking. So what about the other way around? What makes a claim like 1 true? Well, we might think that there are a bunch of singular causal claims, and if enough of those singular causal claims are true, that makes the general causal claim true. But we'd want to know a little bit more about that pattern. So what we just saw is just because an individual, for example, smokes and gets cancer, we can't infer, right, that the smoking is caused by cancer. So what we want is a general view about the pattern between individual statements such that enough of the individual statements will provide support or will make true the general causal statement. So we come now to a fundamental divide in how individuals think of causation. So there are 2 basic ideas. The first idea is that causes are connected to their effects. So there's a sort of energy or process or mechanism by which a cause will bring about its effect. There's a definite sort of connection there. Think, for example, of a billiard ball that is struck and moves across the table and then hits another ball. There's a transference of energy from the movement of the one ball to that of the other. Another idea, very different idea, is that causes make a difference to their effect. So what we'll see in a minute is that with causes, it's often the case that if the cause hadn't occurred, the effect wouldn't occur. A fundamental divide in how one thinks about the nature of causation is whether they take the difference-making idea or the connection idea as the most sort of basic or as the key to causation. If you take the connection idea, you're going to be attracted to accounts that stress a causal process or a mechanism whereby the cause produces the effect. If you're attracted more fundamentally to the difference-making idea, you'll be attracted to the idea that ultimately we can use something like a counterfactual to analyze causal relations, where the counterfactual is a claim that if this particular thing occurred, then this other thing would occur. In the case of trying to understand difference-making and causation, we talk about what would happen if the cause didn't occur. Would the effect still occur? So a difference-making account will say if the cause didn't happen, the effect wouldn't happen. Symbolically, a counterfactual is written as a box arrow. So, for example, the claim I have there on the screen we would read as if C were not to happen, then E would not happen. Most causal relationships have both connection and difference making, but there are two main classes of problems, each posing a different challenge to either difference making or connection. Omissions are causes that make a difference without a connection. For example, I forgot to turn the burner off. The kitchen burned down. My forgetting, this omission, caused the fire. You're like, why did your kitchen burn down? It's like, well, I forgot to turn the burner off, and I left it on all day long. If I hadn't forgot, there'd be no fire. But there's no process from my forgetting to the fire, even though the forgetting is the key difference maker for the fire. So we want an account of causation that can make sense of how omissions are causes. This obviously puts pressure on the connection idea being fundamental. A different problem is overdetermination. So overdetermination is when one event causes another, even though it makes no difference to the outcome. Classic example here is a firing squad. So no single shot makes a difference, but some single shot caused the prisoner's death. So there's a connection there, but there's not difference making. Any particular shot doesn't make a difference to whether or not the prisoner would have died. So this obviously puts pressure on a counterfactual analysis of causation. And for counterfactual accounts, you want to be able to say something about overdetermination and how you can have causation in the face of overdetermination when it's not the case that if the particular cause didn't occur, then the event wouldn't have occurred. Another question that we want an account of causation to be able to answer is to tell us about the nature of the causal relation. Is causation a basic relation, or can it be analyzed in terms of other, more basic relations? In the background here is this idea of reduction, of having a successful analysis of a thing that reduces something complex to its more basic elements. Take, for example, genes. Genes are the things which explain inheritable traits, and we come to find out that genes just are segments of DNA. Genes, that which explains inheritable traits, is nothing but segments of DNA. We can think of this as a reduction, taking the concept of gene and replacing it with the idea that what this is just a segment, certain segments of DNA. Reduction itself can be iterated. So DNA is a double helix structure bound by sequences of bases. These are the A, C, G, T. And so genes are nothing but a double helix bound by sequences of bases, A, G, C, T. So David Hume offers a regularity theory of causation, which is an attempt to analyze causation in terms of a more basic relation. We'll get into this in more detail later, but the basic idea is that A causes B, in virtue of which all A's are regularly followed by B's. So Hume, as we'll see later, dispenses with the idea that there's some sort of necessary connection or some sort of causal necessity between events. He thinks, no, causation at its root is the idea of a regular succession of events. Counterfactual theories are another theory attempting to give an analysis of causation where A causes B is to be analyzed in terms of the truth of a particular counterfactual claim, that if A were not the case, then B would not be the case. A very different account of causation takes causation to be a basic relation. A causes B isn't something that has a successful analysis. It's a basic concept, one that we can glean directly from experience. We'll see an example of this with Elizabeth Anscombe later on. And finally, another question that we'll want to get answered is what kinds of facts are causes? So take, for example, turning 18. In the US, as soon as you turn 18, that causes you to become an adult. But this causation isn't, in a sense, like a state of the world. It's not like a causal process. It's just a legal fact. So are legal facts the kinds of things that can be causes? So in general, we want to know what kinds of facts are causes. Does one's birth cause one's death? There's obviously a connection from birth to death. Moreover, if you hadn't been born, you wouldn't die. So there's a counterfactual claim that's there. But it seems weird to say that one's birth causes one's death. Might we approach this from a scientific perspective and think that one's birth is a causal factor in one's death? So what we want is to identify principles by which some events are causes and others aren't. So for example, we'll want a theory that will tell us whether or not one's birth is also a cause of one's death, and in virtue of which one would think that or one would not think that. And moreover, we want to explore how these principles depend on different kinds of facts. All right, so next up, we're going to look at a history of causation.